Hi, in this video we'll review vector components. Let's start with another example. Imagine a plane is taking off with a velocity of 150 miles per hour at an angle of 30 degrees above the horizon. What you see here is the plane's velocity vector. Let's talk about x and y components of this vector. The x component, Vx, tells us the horizontal portion of the diagonal velocity, or in other words, how fast the plane is moving forward, while moving at 150 miles per hour at an angle. Likewise, the y component, Vy, tells us how fast the plane is moving up. Because this is a right triangle, we can use trigonometry to calculate the magnitude of each x and y components. Let's start with Vx, the x component of the velocity. It's adjacent to the angle theta, meaning next to it. So we'll use cosine theta to relate it to our velocity, which is the hypotenuse. As you know, cosine theta is equal to the adjacent Vx over the hypotenuse v. If we solve for Vx, we get Vx equals v times cosine theta. Substitute our value for the v, the velocity vector, and theta, the angle, and we get a speed of 130 miles per hour. That means that while the plane is actually flying at 150 miles per hour at an angle, it is flying forward at 130 miles per hour. Let's do the same for the vertical component. The y component of the velocity, Vy, is opposite to the angle theta, so we'll use sine theta to relate it to our velocity, the hypotenuse. Similar to before, sine theta is equal to the opposite Vy over the hypotenuse v. If we solve for Vy, we get Vy equals v times sine theta. Substitute our value for the v and theta, and we get a speed of 75 miles per hour. That means that while the plane is actually flying at 150 miles per hour at an angle, it is flying upward at 75 miles per hour. Pulling all of this together, we can see the actual velocity of 150 miles per hour, then what that means in both the x and y directions. Of course, we can do the reverse too. If we know the x and y components and need to determine the magnitude of the actual velocity v, we can use Pythagorean Theorem, which states that the hypotenuse c squared is equal to the adjacent side, a squared, plus the opposite side, b squared. Applying the appropriate variables for this problem, we get v squared equals vx squared plus vy squared, and we solve for v. Substituting our known values for vx and vy, 130 and 75 respectively, we get the final result of 150 miles per hour, which is what we expected. Awesome! Now we're at a point where we can learn how to do this with computer programming.